okay, just for my understanding that how much each of you knows about cloud computing, about AWS platform. We are going to cover each and everything. After that, you're going to take all the assessments, then you will see the difference. Okay, so don't worry. And good evening, Shapna. Okay, guys, so let's start today's session. So yesterday, and I mean on Tuesday, we have discussed. First of all, we have seen that there will be two component of this course. The first one will be your foundation. The second will be your architecture. And under the foundation, what are the different 10 modules? What all content each module will have that we have seen yesterday. After that, I have told you something about certifications. How many certifications are available on AWS platform? Apart from that, how you can which certification we are aiming for. After that, how you can grow yourself in the field of AWS. So we have discussed that. Now we are going to discuss about AWS documentations. Okay, so how you can use these documentations effectively, because these documentations are created by AWS engineers, the solution architect, the team which is working inside AWS has created these documents, because this AWS is the product of Amazon. So they have hired people who can the subject matter experts who can write all the documentation, so that it will be helpful for all the people or all the customers who are going to use this particular platform for creating the application infrastructure. Okay, so that's why today I'm with you for 80 hours. So any questions are there, you can ask me. But after this, you have to be on your own. So as you will grow in your career, you will have new challenges. Please mute yourself, guys. Please mute yourself. It creates a lot of disturbance. If you have any kind of a question, just ask me in the chat. I'm going to answer each and every queries. Somebody has unmuted. I'm getting a little bit disturbance. Please mute off. Yeah, good. Okay. So in future, whenever you're working on any issue, suppose in your project some new requirement is there which requires a new service. Now from where you should get the detail about that particular service. So you are going to research AWS documentation. On the AWS documentation, you are going to have all the details from basic to advanced, all the details about each and every AWS services. If you have any query, you can check inside the AWS documentation. You can consider it as a Wikipedia for AWS, these AWS documentations. Okay, so let's check out. So this is the URL, guys, AWS documentations. That is docs.aws.amazon.com. Okay, let me copy it and put it in the chat. Okay, so I put it in the chat. You can copy it from there. So this documentation, look at this. Currently, it is having all the details. So these are all the feature services, the compute services, the container-based services, storage, any services. If suppose you are having 70 plus individual services created by AWS, you will get each and every details on this particular documentation page only. So this is very, very important. Please read out the documentations. If you have any issue, please check out this documentation. It is going to help you a lot in your features as well. Okay, so let's see. So this is the URL. Now, one is the white papers. So AWS also publish white papers. White papers contains all the latest news about a particular service. Suppose they have done some research. Okay, suppose there was any issue which was currently inside the AWS. Some requirement was there which needs to be fulfilled for a particular customer that was not there in the AWS platform. So when they are going to implement that particular functionality in their AWS platform, that time they're going to write a research paper in the form of white papers. So you can also read out the white papers. You can this is the URL, amazon.com white papers. This is the URL for white papers, where you will get all the details about the white papers. Let me just show you this URL as well. So these are all information parts. Okay, so if there is any modification done any particular service, then you will get all the details about inside the white paper. So you should always refer your white papers and documentation for getting any answers on AWS platform. Okay. So these are some of the, URLs are also there, which are related to your, this particular AWS only. Suppose if you want to check out the overview of AWS, you can get on the documentation part, the architecture for the cloud, anything, the, how this AWS pricing works, what is the total cost of ownership in the cloud, all those details you will get under the white papers and under your documentation. Any doubt, anytime, just check out the documentation. That is a simple funda of this AWS documentation. It is just your Wikipedia. So on your Google, whenever you face any issue, you just type that query on the Google. So whenever you're typing any query, it's going to first give you the link for documentation only. Suppose if I'm typing something like Amazon S3, okay? Amazon S3. So look at this. If I just scroll down, look at this. What is Amazon S3? It is giving me a URL of docs.awsamazon.com. So it is going to direct you to this official website. That's why you will get a genuine content which is created by AWS people only. Okay. Okay, so let's go ahead. So one activity is there. It is not any activity, I would say, just a simple steps how you should use these documentations efficiently. So let's check out this. So first one is there, okay, what guides and references exist for Amazon EC2 services. So they are telling that when you will search for EC2 on documentation, you can see there will be guides for Linux and Windows machines. So when we are going to discuss about this EC2 mainly used to create the servers. So you will have all the guide how to create your Linux servers, how to create your Windows servers, your Mac OS servers as well. And then what are the different APIs references? I will tell you about what is API in the coming section. Okay, I will tell you what is API, so don't worry. Then your AWS CLI references. CLI means command line interface. Okay, so suppose you don't want to use this management console, which is a this visual a graphical and a visual form to use your AWS services. Suppose if you want to do it through the command line, then all those commands will be there on this particular EC2 this EC2 service documentation page. You will have all the instance connect references and your user guide for auto scaling, how to use the auto scaling, how to implement the auto scaling, and how to import and export the VMs, the virtual machines, from your on-premises to your AWS and vice versa. So all those things, any questions, any particular information related to EC2 will be there on this particular guide page. Suppose if I'll come here, if I will search this EC2, so now look at this. You will have all those. Look at this. User guide for Linux, user guide for Windows, user guide for this, Amazon Day2 enclave, some, advanced type of servers, API references you will have. So all those things which we are talking about. Look at the CLI references. So we have all those details, the auto scaling. So in this activity, they just want to tell us that, with the help of this simple question, they want to tell us how you should search your content. Okay, if you want to have any doubt, if you want to learn any particular service, just refer documentation. That is a simple, a conclusion of this particular activity. Now let's check out the another question. Now they're telling, can you find the documentation that describes how to create an S3 bucket? So they have given some steps. First, you have to go through this URL. So what is this URL? docs.aws.amazon.com. It is a AWS documentation URL. After that, you have to click on S3. So under the services, you have to click on S3. Then you have to click on getting started guide, and finally you will get option as how to create a bucket. So let's check out that also. So suppose I am here on the documentation guide. Okay, so any doubt if you're having, if you will directly just search it on the Google, it will give you the corresponding docs page, the AWS document page, and you can search out for that. Okay, so what they were telling, they want to check how to create a bucket. So select this S3 service from here. Okay, and under the user guide, they were telling then you have to move to user guide. And now look at this. Under the user guide, you will get getting started, and this is the first step, how to create a bucket. So that's how you can search for your query on your documentations. Okay, so let's move ahead. Now they're telling, can you find a one sentence summary of AWS Cloud9 service? So Cloud9 is an ID, integrated development environment. If anybody don't know, I think people who are currently working in IT, they know what is ID. If you're not working in ID or you're from non-technical background, then I'll tell you what is integrated development environment. So it is an environment which is which is used to which is for running your code, okay, your programming language code. So for example, if you're using a Java, we have a Eclipse ID. So first you have to download the Eclipse. On the top of that, you can create a Java project. Then you have Microsoft Visual Studio for your .NET project. So that is the ID. Now what is Cloud9? Cloud9 is a cloud ID. So they have created a cloud-based ID where you can write your code, where you can run your code, and where you can debug your application code. So if you don't want to use any particular ID in your local machine, you want to use a cloud-based ID, then you can just simply use this Cloud9 service, and this service is available on your AWS Management Console. You just search for Cloud9, and you can just set up the ID for your particular application over there. So it is just a cloud-based ID where you can write your code, where you can run your code, and you're going to debug your code. So this is kind of if you are going to search for Cloud9, you're going to get this kind of details. Okay. Now suppose they are telling which programming languages does the AWS Lambda Service API supports. Okay. Debug code means, Manish, debug code means, suppose you have written your code and your code is running in the production environment. That means the users are connecting to your application. Now, for example, after 6 months, some application bug has came. So suppose I was using your application, I'm your customer. So I told that this particular button is not working. In your application, this particular button is not working. When I'm clicking on this button, I'm not getting any response. The response is blank. Okay, then developer will get that particular ticket. Now suppose you are the developer, Manish. So now how you are going to resolve that issue? That means you have to debug the code. You have to check out the code, okay, from where that particular, once you are clicking that particular button, which function is running in the background. That function is calling which other function. So that's how we are going to, with the help of the debugging of that code, we are going to resolve that issue. So this means we why we debug the code? To troubleshoot the issue. Whenever you will get any issue, suppose you are doing a development, and now that whatever feature you have created, now it went to the test team for testing that particular feature. Now they have raised some concerns. They told that this particular functionality is not working. Then how you are going to resolve that issue? You're going to resolve that issue by debugging your code. So debugging your code means just checking out, just checking out which particular function is calling which particular function, what is the functionality of that particular, that feature of an application, and based on that you're going to troubleshoot the issue. Then you're going to make the changes in the code. Then you're going to rebuild that particular code. So yeah, it is just for a root cause analysis. Yeah, Manish, is it clear? Manish, just confirm me yes or no. Okay, so no answers yet. Okay, just ping me, okay? Don't unmute. Okay, please ping me, don't unmute. Okay, so now let's check out the question number 4, guys. Which programming language does the AWS Lambda service support? So yesterday I told you AWS Lambda is a compute service which is used to create a, what do you say? It is a compute service which is a serverless service. So they are telling that this AWS Lambda supports which all programming languages. So once you will go to this documentation, you have to first go to this main page, search for AWS Lambda. Under API references, you are going to click on getting started, and there you will find all the programming languages which supports AWS Lambda. So this AWS Lambda is a function as a code. When I'm talking about function as a code, it is one of the cloud service module. Okay, so inside this function as a code, we are going to write all the functions. So it is asking, when you're writing this Lambda functions, this Lambda function supports which all programming language. So here we have the answer. It supports all the major programming language which currently we are using in the IT industry, starting from Node.js, your Java, C#, Python, Ruby, Go, PowerShell, Docker. It supports everything. So it is a very versatile platform. You don't have to worry. There is no limitation. Let's suppose you have built your application in Java. Now you want to check whether you can create any Lambda functions with the help of Java. Yes, you can, because it supports the programming language. So like that, it supports all the major languages. So it is just giving you, how you can search your content on the AWS documentation page. Now let's check out the 5th question. So find the tutorial that describes how to run a serverless Hello World application. Then scroll through the AWS documentation steps What two AWS services does the tutorial have you used? So currently I've told you what is the serverless service. The serverless service in AWS is your Lambda. So one will be the Lambda and other will be your that is CloudWatch. So CloudWatch is a monitoring service which will be automatically integrated with your Lambda. We are going to go through each and everything in detail. Just since it is under the answer, so I'm just telling you a little bit overview. So it is automatically integrated with your Lambda, which is with your Lambda. So this CloudWatch is going to monitor your Lambda function. So that's why they are telling these are the two services which are used to create the serverless Hello World application. Okay, so this is a simple answer of that. Okay, so what is serverless? Chinna is asking. Serverless means like it is a like they have created a thought for you that you don't have to think about the server. That these Lambda functions are not running on any servers. Though some servers are there, some hardware is there, but AWS Lambda is a fully managed service where you don't have to create the machine. Let me take an example of EC2. EC2 is not a serverless machine. Now, what is the difference between EC2 and Lambda? That I will tell you. Then you will understand what is serverless. Since EC2 is a service-based, service, what will happen here? So from here, first you have to create the whole server. You're going to create a machine, a Linux machine or a Windows machine. That will be your server. On the top of that, you're going to deploy your application. But whenever you are using your Lambda, that time you don't have to create any machine. You can directly write your code. You don't have to worry about your underlying hardware. So it is just a thought. Though hardware will be there, but that hardware will be for Amazon. So they are only managing that part. But from our side, we are directly writing the code on a particular serverless platform where we don't have to think about any server. There is no server concept when we are using Lambda. We just have to worry about our programming code. We don't have to manage the servers. So when you don't have to manage the servers, when you don't have to create any server, when you don't have to upgrade any server, that whole architecture where there is no involvement of creation or upgradation or maintenance of any server, that architecture is known as serverless architecture. I hope Chinna it is clear. Is that clear, Chinna? Just confirm me. Okay, great. Okay, guys. So these are the simple 5 questions, okay, which will just help you. And just simply like they are going to help you to find the information on AWS documentation. Yes, we can use this. Like we can use this, Durga. We can use the Lambda services for creating the applications mainly for the automation purposes. So once we will go to this particular, this topic, we have Lambda under the compute services. I'm going to explain you what is Lambda, where all you can use this Lambda. What are the use cases of Lambda? So for now, you can understand Lambdas are used for automation purposes. Okay. Okay, guys. So let's check out what's there in this particular thing. So this is a module wrap up. Okay. So this was all about in this particular introductory module. Nothing was technical. Only the details how you can search anything on your documentations. What are the different like certifications are there, and what is the course structure? How many modules are there inside our course, and what all details are there? So that was about the summary of this particular module. So let's now start with the technical part. So some additional rules are there. Our certification, cloud practitioner documentation. So once you will get this access, so under the student guide, guys, under this student guide, there will be a student guide. So whatever these PPTs, whatever I am running, these are under the student guide. So you can check out these resources. These are nothing but your documentation and white paper resources. That's it. Okay, so let me just close this and let's start our module number 1. Okay. Just a minute. Oh, somebody is raising up the hand. Okay, guys, if you have any kind of a problem, just ping me in the chat. Okay, somebody is raising the hand. Any kind of issue, just ping me in the chat. I'm going to answer that. Okay. Please don't raise it.
For me, chat option is not available, sir.
Sorry, your voice is not clear. Please write your query inside the question.
For me, chat option is not available in this system.
No, you don't have to go for the chat. Can you see the questions section? Questions. Question section is available for you. It will be it will be on the top. It should be there. For others, it is available. They are able to write me. Can you
Probably
just
on
check out?
show control panel, mic symbol, and view window mode, and the raise hand. These four symbols only it is there.
Okay, but usually it is available for each and every one. I'm not sure why you're not able to see. You just try to reconnect, but it is there.
Okay, I'll reconnect it.
Yeah, please. Okay, it will be under polls. No, not under polls. It will be just above your handouts. You will get one question area where you can post your questions. Okay. Okay. Okay, guys. So the telling this PDF will contain all the links are available for. Yes, it is available for you. Whatever content I'm going to show you here. Okay, everything is available on your platform on the Canvas platform, guys. Okay, so you don't have to worry about this part. Okay, apart from that, somebody is asking me. Okay, somebody is asking me. Tell him to enlarge the box by clicking on arrow. Okay. Okay, so we got some, suggestions. Or somebody was not able to access that particular, this question area. You can just click on the arrow. It is going to enlarge the box, and you can check it out. Canvas ID pass, you will get it from Ethnus. I think maybe next week you're going to get your Canvas access. Then you can check out all the reference materials. Okay. Does the whole course will be in theoretical matter? No, it won't be in a theoretical manner. It will be in the combination of theoretical and your practicals. So we have a different kind of a labs. You're going to go in a sequential way. Once there will be any lab like this, okay, you're going to do the lab, guys. But first three modules will be your theoretical because it will be concept based. Then once we will start with the services, then we are going to check out the demos of those services. Okay. Yeah, I'm teaching it from zero only, money. Don't worry. We have not yet started. Now we're going to start, so everything will be from very, very basic level. Okay. So Ganjan is asking, sir, what is Lambda? AWS Lambda, Ganjan, don't worry. AWS Lambda, we're going to come to that topic. Currently, I'm not explaining anything. I just told you AWS Lambda is a serverless service which is used to where you can write your functions, the Lambda functions using different programming languages. Just this thing you have to understand. Once we will deep dive, once we will be reaching to this particular module, we are going to deep dive on this particular topic. Okay. Okay, guys. I think I've taken all the yes above mute option. There will be right arrow. Okay, guys. So let's start now. Okay. So I think I've answered all the queries. So now we're going to start with module number 1, which will be your entirely on the cloud concept overview. Let's see what all topics we are going to cover in this module. First, the introduction to cloud computing. Then advantages of cloud computing. After that, introduction to Amazon Web Services. Please mute yourself, guys. I'm just requesting you. I'm getting a disturbance. Please mute yourself. And finally, AWS Cloud Adoption Framework, which is AWS app. So these will be the 4 topics which we're going to discuss in this particular module. So after completing this module, what you're going to learn? First of all, you'll be able to define different types of cloud computing models. What are the different kind of cloud computing service models? What are different kind of cloud computing deployment models? We're going to learn that. After that, you will be able to describe the 6 advantages of cloud computing over the traditional computing. Okay. And after that, recognizing the main AWS services categories and core services. So what are the different kind of AWS services which are there on AWS platform? We're going to see that. And finally, we're going to review the AWS Cloud Adoption Framework, also known as AWS CAF. So with the help of this framework, all the company who want to move to AWS Cloud can take their decisions. So we are going to learn this particular framework in detail. So let's start with introduction to cloud computing. So as I told you, like in our last class, I told you what is cloud computing. It is a very simple definition with a very simple definition that it is just a combination of your internet and your it is just a combination of your virtualization and your internet. So one more definition is there. Let's check out this. Cloud computing is the on-demand delivery of compute power, database, storage, application, and other IT resources via the internet and with pay-as-you-go pricing. The same thing. So whatever thing are there on a physical hardware. Suppose like if I'm owning any company, let's go back to 19th century, okay, where there was no concept of cloud computing. So then also companies were there, IT companies were there, they were doing the business. But at that point of time, they were having all the physical hardware owned by them only. So now with the help of cloud computing, we are not owning any hardware. That hardware is owned by some other third party. We are just using it as a part of a service, or you can say infrastructure as a service. So cloud computing, with the help of cloud computing, you're getting an on-demand delivery. Suppose you want server, you can get it on demand. You want a database, you can get it on demand. You can pay it on demand. You want a storage, you can get a cloud storage on the demand. And all the other IT resources which are required to build, or which are required to build the application infrastructure where your application is going to be hosted. And how you can access this virtual world? With the help of internet. That is the medium to which is the medium to access that all the virtual components or virtual application infrastructure components. And now how the pricing goes, it is pay as you go. So now suppose I've created one server. Today I created one server on AWS platform. I've used that server for 5 hours. So I'm going to be built for only 5 hours. So whatever things you're going to use, for that you're going to be paid. For that you're going to pay to AWS. That is a simple funda. Pay as you go. Suppose I created one database, 2 servers. So for that one database server and 2 web servers, I'm going to be paid per hour. That's it. That will be the billing part. AWS is going to bill me only for those 3 machines, and for the number of hours I'm going to use those 3 servers. Suppose all these three machines I have used for 1 month. So I'm going to be billed for that particular time only, and only for those 3 machines. That's why it is telling pay as you go. So whatever you are going to use, for that you're going to pay from your pocket. There is no extra charges. That's why this particular model is very, very successful, and it is saving a lot of money for the company. Okay, so now first let me just tell you, okay, why cloud computing came into the market, what all problems it has resolved. So if you will think of any successful business, or suppose any business, there are 2 major components, guys. One is your time, other is your money. These are the very, very important components of running any business. So first of all, let me compare this cloud computing with the with the traditional computing. This cloud computing infrastructure with the traditional infrastructure. So what happens in the traditional infrastructure? Let's go back to 19th centuries, where this cloud computing was not popular, and people were heavily relying on on their traditional infrastructure. Traditional infrastructure means the infra, that is the physical, all the physical machines are owned by the company. Suppose Infosys was there in 19th century. So that particular company, when they have started, suppose they have 10 offices. Now to get the details about to host their own internal Infosys application, to host the data of their employees, they would be having a separate data center. So all these physical hardwares are located inside the data centers. So data center is a place where all your physical hardware, your servers, your storage, your databases, your networking components, your subnets, your load balancer, everything is placed and everything is attached to each other. And on the top of that, you're going to deploy your application. So everything will be purchased by Infosys only. Because that time there was no concept of cloud computing. So that was traditional infrastructure. If suppose tomorrow I got a new client, Infosys is a service-based company. So suppose one new client came to Infosys and they told that you please take care of my application. You have to build my application and you have to support my application. So Infosys have to order the infra first. They have to order the infra first. They have to talk to their vendors. So they have to just order the infra. They have to order the infra from their vendors. Then all the machines will come to the data center, like your web servers, your database servers, your storage, etc. And then data engineers will be there. They're going to assemble each and everything. After that, they will assemble each and everything. Then they're going to test if all the infra is working as per the expectation. Then your developers come and they're going to deploy the application. So now, if you're using this traditional infrastructure, what is going to happen? First of all, you're going to lose a lot of money, because to create a particular data center, it requires a lot of money in millions of dollars. Okay, lot of money is required, because first of all you have to buy or rent a land. Okay, and that particular land you're going to create a data center, because data centers are very huge. Then you have to build that whole data center. It requires a lot of compute. It requires a lot of cooling, because all these machines. For example, you are using a laptop, like you're using a laptop or your PC. It generates a lot of heat. Like that, lot of servers will be there in that particular data center. So you have to maintain a cooling inside that particular data center. So you have to invest in that also. Then you need some physical security, some people who can who can secure your data center. Then you need some data where as this data engineers. Those are going to assemble all the components. So this is a lot of cost is there. A lot of cost is generated before deploying any application. So here people were losing a lot of money in creating the data center, in buying all the resources, for assembling all the resources, for the security of that particular data center. A lot of money is wasted. So that was the one problem. Second problem, time. So suppose today, I was suppose I was owning a company and I was using a traditional infrastructure. I was having an e-commerce company. Okay, and now what is it? Suppose 6 months after there is a Diwali sale. So I have to plan it from now. I have to guess that currently 50,000 customers are coming to my application. That is the application traffic. And on the occasion of Diwali, I am expecting, based on the charts, I am expecting I will get 1 lakh people on board on that particular day. So for that, I have to arrange more infra. So now, based on that, I'm going to call my vendor that please provide me, 10 servers, 5 load balancers, 2 networking components, like that. So that vendor is going to provide you everything, but it will take some time. You're not going to get everything on demand. You're going to get everything in some time. Suppose you get all the infra in 1 month. You have called some vendor. He is located 700 kilometers away from you. Then first of all, he has arranged everything for you. Then he has load everything on the trucks and send it to your data center. Suppose 2 weeks it took for all those hardwares to to get to your data center. Then your hardware engineer will come and going to assemble everything. To create that infra, it will take almost a month. That's where you are losing the time. Okay, suppose if you want today, you are running any application using traditional infra and you want to increase the capacity, you want to increase the servers, and if you don't have anything in your reserve, then you have to buy the servers and you're not getting it on demand. When you get, suppose, we are shopping online. If suppose you are going to Amazon.com, you are buying any laptop, are you getting it within 5 minutes? No, it will take few days. Maybe the fastest delivery will be within 24 hours, but there will be a time delay. So with this with this traditional infrastructure, we are losing both money and time, because lot of money is wasted in creating the data center, in creating in getting all the components, arranging all the components, assembling all the components, and lot of time is wasted because all those getting all those components, arranging everything will take a lot of time. After that only you can deploy the application. But now when this cloud computing came to the market, both these major problems for business people got resolved. Now with the help of cloud computing, as this particular definition says, it is a on-demand delivery. So today, suppose you are running any e-commerce application, you find that you are getting more customers. Then simply you can create one more server and add it to your existing infrastructure. You don't have to worry about anything. So it is saving a lot of time. Second, how it is saving our money? Since you are not owning any infra, we are just renting out the infra from AWS. This whole physical servers are owned by AWS. They are just giving it to us to use it as a particular service. So we are not owing anything. When we are not owing anything, we don't have to waste our money for that. We can use that money for our application development. Whatever, suppose, I'm using 5 servers on that particular AWS platform. So I'm going to be only paying for that particular 5 servers. Apart from that, I'm not going to pay anything to AWS. So a lot of money and lot of time has been saved using the cloud computing. That's why this was a, very, I would say this is a very, revolutionary technology which came to the market. And now you see, India only, we're getting a lot of startups. A lot of startups are coming to the market and they are converting those startups to unicorns. How it is possible? Because, if you will go back in the 90s, this funding concept and all, this angel investors, those were not so much common, okay? People have to first think that they have to invest a lot in infra only to create any IT company. But today, just you have to get the developers, create the AWS account or Microsoft or any public provider account, and then just create the infra and deploy your application. That's it. You will get your bills in monthly basis or yearly basis, whatever subscription you're going to take. So that's why, like this give an, like advantage for the startups so that they can bring their product in the market. That's why you will see a lot of startups are coming in Indian market only. But if you will go 10 years back, you will see the startups were very, very less. People have to think twice because they have to invest heavily before and only. But now they know that they have to invest very, very minimum to and their product will be launched in the market, because they don't have to like they don't have to buy any infra. All the infra will be provided by the public cloud providers like Microsoft, AWS, Google, etc., etc. Okay, so now you got why cloud computing came to the market, what all problems it has resolved. That's why it is a very good technology to learn. And like I would say like this will be like this technology will be there for over the period of time. So it will be a good for your future perspectives also. Some questions are there. Okay, which platform is a good, AWS or Canvas? No, like it is same only, Abhishek. Actually, don't create the AWS accounts, guys, because on Canvas when we are doing lab, and we have also provided you the sandbox. So what happens sometimes, with this AWS free account, whenever you are using this AWS free account, I will also show you the video how to create the AWS free account tomorrow. But you don't have to create it now. Okay. Why you have to use Canvas? Because Canvas are the labs where you will perform your lab, and after that, like all these resources which you have created will be automatically deleted. So in our in our labs, we are going to use some resources which can charge you. Because if you will use a free account also, AWS free account, then too it is having some limitations. Okay, so it will give you a free hand to use the services, but few services are few, but few are charged. So we don't want you to get charged. So first, use when till the time you have the Canvas access, you can do everything on Canvas like you can do in your own private AWS account. So you have the lab part, you have the sandbox part. So please use this use this particular platform, and it will help you a lot. Okay, please don't create the account. Once this Canvas access has been revoked, then you can create the AWS account. I will tell you the steps tomorrow how to create the AWS account. It's a very, very like basic steps are there, but I'm going to tell you tomorrow. Okay, then one more is there. What is meant by deploying of application? Okay, so Prasad, what deploying the application means, you have created the application. Suppose look at this. This is the application. This is your application, which is consists of the programming language. Like you have used that Java programming language, and you have created a Java application. Your e-commerce application using Java. Now, how this application is going to run? So it is going to run. How is it going to run? It's not going to run like that. Now you need some underlying infra. So when you deploy this application on this particular infra on that particular server, that is known as deploying of application. So you have to put your application on this infra on the top of this particular layer. Then how to put it? With the help of deployments. So that is the simple meaning of deploying your applications on AWS infrastructure. I hope you got the answer. Okay. So now he's also one more. He's asking one more question. Does the vendor provide servers, infra, or the cloud computing concept is to rent out all these application components. So vendor is going to provide you everything. AWS is the vendor which we are going to learn. AWS is going to provide you everything in the form of services. They will provide you compute. They are going to provide you storage. Now, as per your requirement, as per your project requirement, you have to use those services. There are different kind of services for AR, VR, virtual reality, for machine learning, for compute, for networking, for security. You have different kind of services. A very vast service catalog AWS is having. In that, whatever is of your need, whatever is of your requirement, based on your business requirement, you can use that. So you are just renting out that. All those belongs to AWS. What we are doing, we are just renting out. We are just taking it from them for suppose for few hours or few years, and we only have to pay for that particular hourly charge. Please mute yourself.
Sorry to interrupt. Actually, I am unmuted. So sorry to disturb you. Actually, my question was not that. So I want to ask that in 90s, while we are using traditional infra, at that time vendor used to give the infrastructure or servers for rent, or we need to buy them at that time.
No. You have to buy them. Suppose currently you are going to buy a laptop from Lenovo company, Will they give you for rent? You have to buy it from their store. Then you can use the same concept. Those vendors are the company who create these, servers. Okay, suppose HP servers. So you have to buy it from them. That's why it is costly. If the concept of renting was there, then I think there was no need of cloud computing. We were able to, like everybody can have their infra without any issues. Okay, that's why.
And one more question is there.
Please put it in the
this-
chat. Please put it in the chat. Okay. Yeah, please.
Yeah.
Thank you. Okay, guys. Okay, what is server means? Server is nothing but a machine. Your laptop is one server. So currently, you consider your laptop as a server money. So when you're running any application, on server. Consider your laptop as a server. On the top of server, you're going to run your application. Okay, so that is the meaning of server, which runs your application. Okay, simple. You got that? Okay, guys. So let's go ahead. Okay, Prasad is asking one more question. Why we need multiple servers when we have high traffic? Okay, every machine is having a limitation. So currently, suppose you are using a laptop of 4 GB RAM, of 100 GB hard disk. Suppose, like there's any application, okay, suppose these are and like your CPU is there. So suppose like there's a threshold of 4 GB of RAM, there's a threshold of 100 GB of hard disk. Those are the threshold. So that's why if suppose you have a more traffic which is above the capacity of your machine, then you need multiple servers, and all those servers will help you to balance that whole customer traffic load, or I would say all the load. So that's why we need multiple machines, because every machine is having a threshold. Okay, that's right. So we are going to come that. Okay, just listen to me carefully. Once I'm going to tell you what the advantage that I'm going to tell you, why we go for multiple machines and all. But for now, you should understand that why we use multiple machines, because every machine is having a threshold. Okay, so it will be all the resources that the machine will be exhausted at any point of time. That's why we use to distribute the load to multiple servers. And if you're using a single machine, suppose of very high configuration, then what will happen if suppose that machine got failed, then the application is down. That's why we use multiple servers. Okay, guys. Yeah, backup servers are different, Raghuveer. Backup servers are different, but you can say for the highly available, to make your application highly available, we use multiple servers. Okay, so let's now understand what is infrastructure as a software. So with the help of cloud computing, it will enable you to stop thinking for your infra as a hardware. Infra as a hardware was in traditional computing, traditional infrastructure. Now with the help of cloud computing, you always have to think that you are creating the infra with the help of software, infrastructure as a software. So this is one of the difference between the a traditional infra and your cloud computing infra. In traditional infra, we used to create infrastructure with the help of hardware, because first we have to buy all the hardware, and those once you will get all the hardware, you have to assemble all the hardware, then you need to deploy your application on the top of the hardware. But currently, when we are using this cloud computing environment, we have to think that we are using this infra as a software. So let's consider the example of AWS. So what AWS is doing? AWS is providing you all this hardware in the form of services, in the form of softwares. So once I'm going to log into AWS Management Console, there will be different services like EC2 will be there, Lambda will be there. So there will be some hardware which is owned by AWS. But what they have done, they have created the services out of these hardwares, so that we can use these services to create the application infrastructure. That's why in cloud computing, we have to think like infrastructure as a software, and inside the traditional, we have to think like infrastructure as a hardware, because there we are owning all the hardware, and inside the cloud computing, we are not owning a single piece of hardware. Everything is rent out, and you can use it in the form of different AWS services. Okay, let's move ahead. No problem, Venkat. We are just discussing. We have just started discussing the cloud computing concepts. So it's okay. You can join it from here also. Okay, now let's check about some traditional computing model, which I told you, the old traditional model. which is infrastructure as hardware, where you have to owe everything about from a single piece of nut to a big servers. You have to owe each and everything. You have to buy each and everything first, then you can deploy the application. Hardware solutions, you have to require spaces. Space means a data center. You have to create the staff who can look after that data center. The physical security, the security which can secure your data center. The planning to create a data center, the capital expenditure. A lot of capital expenditure is required to build a particular data center. Have a long hardware procurement cycle. Definitely, suppose there's a life of each and every component. Your laptops are having your life. Suppose for 5 years. After 5 years, you will see the degradation in performance of your laptop. Then you will buy another laptop, exchange your old laptop with a new one. The same way, all those physical hardwares, like maybe your server, your web server, your database server, your load balancers, your routers, any particular hardware, the storage will have a particular life. And once that particular component will reach a particular like end of the life, then you have to replace that component. So that is a long hardware procurement cycle. You have to procure that component in different phases, that particular hardware into different phases, and then at the end of that you have to replace that particular component. So that is an overhead where you have to where you have to maintain all the hardware procurement. Yeah, Kanan, we are going to see that IaaS, PaaS and SaaS services. I'm going to explain you in the coming slides. Okay. So that's why this is an overhead where you have to procure the hardware also. Then third point requires you to provision capacity by getting critical maximum peak. I told you all the traditional infra works on guessing part. Since they don't have any kind of on-demand facility, that's why if suppose currently I have launched any application on traditional infrastructure, now based on the current customer approach to my application, I have to think about after 6 months how much infra I needed, so that based on this guessing the capacity, I will order the hardware. So today I am started with 10,000 people onboarding my application, and after 6 months I am expecting, based on the all the theories, all the guessing capabilities, I am thinking that after 6 months I will be reaching somewhere near to 50k. Now I need more compute power, more storage to handle that particular customer traffic. So for that I'm going to call my vendor, okay, and they're going to send me all the hardware. So that's why it is all about guessing. So with the help of cloud computing, you have to stop guessing, you have to start implementing. That is one of the biggest challenge was there, because currently I'm guessing. Suppose the same thing. Today 10k people are there on my application, and I'm guessing after 6 months I will get around 50k people per day on my application. That is the customer traffic. Now suppose if my guess is right, according to that I have ordered the infra. If suppose after 6 months only I will be able to get only 20k customers, then whatever extra servers I have ordered, that will be with me only, because I can't send it back to the vendor, because I already buy that. So I have to keep it over there. Or for example, suppose for example, suppose there was more application traffic. I was expecting 50k. Now it is 1 lakh. So whatever infra I have ordered, now that is of less capacity. That is of less capacity. Okay. So that is the problem. That was the problem of getting the infra. That was the issue. That's why this additional model was not successful. That's why there was a requirement of cloud computing. Okay, guys. So let's check out what is the meant by procurement cycle. Procurement cycle means, Pradeep, you listen to me carefully, okay? Procurement cycle means to maintain that particular hardware in different phases. You have to procure the particular hardware. Suppose you have buy your laptop. Okay, so you have to, that laptop will be with you. So suppose after 1 year you will see there will be some degradation in your in the performance of your laptop. What you will do? You will update the RAM, because that hardware belongs to you. But after 5 years, you will find now that laptop is not suitable for work. Then you are going to replace this laptop. So that whole cycle of maintaining that particular hardware is known as hardware procurement cycle. Is it clear? Yes or no? Okay, cool. Okay, guys, let's go ahead. Now let's check about cloud computing model. Here we are thinking infrastructure as a software. In traditional, what was our thinking? We are using this infrastructure, we are creating the infrastructure with the help of hardware. But in cloud computing model, we are creating the infra with the help of the software. The second, the software solutions, it is very flexible to use. Okay, it is very flexible to use, like all these cloud computing technologies, and can change more quickly, easy and cost effectively than hardware solution. Definitely, suppose the hardware solutions are you have to wait for longer time to get the hardware, and once you will get the hardware, that hardware will be with you. But suppose when we are using this cloud computing, that time you don't have to worry about anything because you are not owning any hardware. So today, if you're launching three machines and your application is running on three machines, and you found out that three machines are more like those are not enough to handle my traffic, then you can add one more machine. You can change your infra. You can quickly change your infra, and the overall solution is cost effectively, because here you are just paying for what you are using. You are not owing anything. So somebody is asking me to repeat. Okay, so I'll just tell you. This traditional computing model where we were owning everything from the physical hardware to the data center, everything is owned by us. So we are investing a lot. That's why we are losing a lot of money, are losing a lot of time. And there you have to consider that you are creating the infrastructure. Infrastructure means your application infrastructure. We are going to deploy the application. The whole infrastructure solution you are creating as a hardware, because all the hardware belongs to you. But that problem is eliminated with the help of cloud computing model. In cloud computing model, AWS is a public cloud provider. It is a vendor for us. So that is owning all the hardware, and it has created few web services which we are using as a software. That's why the whole solution is infrastructure as a software. Now is it clear, Ashwini? Okay, please respond. Okay, guys. So now it's also eliminate the undifferentiated heavy lifting task. Definitely, lifting goes with your heavy lifting goes with your traditional environment, where you have to call the vendor, get all the machines, those big machines you have to heavy lift, you have to put it in the data center, you have to assemble it. So all those tasks are eliminated. Here you don't have to worry about a single component. Just create all the services. All your application infra using different services, and after that you will be only paying for all the services which we are using. That's it. Very simple concept of cloud computing. Okay, so let's go ahead. Now we are going to talk about cloud service model. So here somebody was asking me about cloud computing. Hital was asking me. So here I'm going to define you about different cloud service models. So here we have three kind of cloud computing models. The first one is IaaS, which is infrastructure as a service. Okay, and then we have PaaS, which is platform as a service. Sure, Prasad. Okay, I'll just go a bit slow. Okay, so guys, we have three cloud service models. So first one is infrastructure as a service. I'm going to explain you everything. The second one is platform as a service, and the third one is software as a service. Now, what is the difference between three? I'm going to explain you with the help of one diagram. So this one diagram is going to help you. Okay. So first of all, let's talk about traditional IT, which is your traditional infrastructure. Now, from networking, from storage, server hardware, virtualization, server database, security and integration, runtimes, application. All these components are required to create a application. Okay, which contains all your software and hardware components. So from networking to application, you only have to manage inside the traditional IT infrastructure. Why? Because everything is owned by you. You are responsible for each and every hardware layer and the software layer also. The program which are created by your developers. So that's why each and everything will have to be managed by you only. Now let's move to the cloud computing models. The first one is infra as a model. Infra as a infrastructure as a service. So when we're using this infrastructure as a service, inside that your networking, your storage, your server hardware, your virtualization, till this, it will be managed by your AWS. AWS is a vendor which we are going to learn. AWS. It will be managed by AWS. Now let me tell you in detail. So AWS owns the data center across the globe. It has all the physical hardwares, your networking components, which is written here, your storages, your server hardware. So it is only managing. whatever issue will be there, whatever will be the hardware procurement life of that particular hardware, it is going to be managed by AWS only. On the top of that, it has created one virtualization layer, which it is only managing, because whatever services which we are creating, that are all virtual services. We cannot touch that particular component. These are all virtual services. So till this virtualization layer, everything under the virtualization layer until this layer is managed by AWS. And on the top of that, whenever we are creating the infra, the whole application infra from our end, that is known as infrastructure as a service, because here you're going to create the servers from scratch. You're going to use EC2 service. You're going to create the servers from your scratch. You're going to create the databases from the scratch. You're going to perform the security and integration from scratch. The runtime environment you have to create, and you have to deploy the application. So all these parts you are going to manage. That's why it is infra as a service, where you have to create the infra from your end. They are only supporting the virtualization layer. They are giving you all the hardware, and they're creating a virtualization layer. On the top of that, you can choose different services, AWS services like servers, databases, security services, and you can build the infrastructure. So here you will have more control. Why? Because you have built this infra from scratch. Because you are having the you are owning this infra. You are owning the infra. Okay, you are Shalate. I think you have not. I think you have not attended the first class. I'll tell you what is virtualization. Let me just complete this topic, then I'm going to tell you about virtualization. Okay, wait for some time. So in infra as a service, we are creating all the application infra which is going to host your application from scratch. That's why we have more control on the infra. So all these services, all these AWS services, we're using to create the infra. That's why it is known as infra as a service. Now let's move to platform as a service. Now what is the difference between IaaS and PaaS? Let's see. So just check out the diagram. Consider on the diagram. So here, look at this. What all things are managed by AWS? The vendors, suppose the vendor is AWS, because we are going to learn AWS only. And what we are going to manage. So with the help of platform as a service, as the name says, it is going to create a platform for us, where we are only going to deploy the application. We don't have to create and manage the infra. So for example, we have one service known as Elastic Beanstalk, where all the infra will be created automatically. So look at this, from networking, storage, server, virtualization, servers, database, security, runtime. Everything is created by AWS only. Developers only have to bring the application and deploy the application on that particular server. So with the help of platform as a service, AWS is providing a platform, a ready platform, where the developers can come and they can deploy the application. So it is very, this PaaS service is more suitable for the developers who don't have any information or very less knowledge about creating the infrastructures, application infrastructures. So what they need, since they don't want to take the overhead to hire another people so that they can create the infra for themselves, they don't have that kind of a budget. So what they're going to do, they're going to log into AWS and use their PaaS services, that is platform as a services. They can use Elastic Beanstalk. So they have to just create one Elastic Beanstalk environment. So when they will create the environment, on the top of that, they're going to deploy the application, and all the underlying layer will be created by. Underlying layer means all the hardware components, or I would say all the application components, like your, databases, your load balancer, auto scaling servers, so your security component, everything will be created by AWS only. So so you can consider a platform as a service as a particular platform which is provided by AWS, where developers can come and they can directly deploy their application. So here it is also increasing the productivity of the developer. How it is increasing the productivity? Because developers only have to focus on their application code. They only have to write the application code, a good application code, a best application code, and they only have to worry about application, not about the infra, because they're not managing any infra, they're not creating any infra. They are just getting a platform from AWS where they are deploying their application. Okay. I'll just tell you. Okay, so thing is that, okay, I'll also tell you about these different components. So networking means your networking components. Okay, where you will have different networking components like routers and networks are there, which we are going to integrate to create a network. You have a storage solution where you're going to store your application and customer data. You have the server hardware. Your physical server hardwares are there inside your inside your data centers. Inside your data centers, we have a particular racks. Inside that, we have servers. Then there's a concept of virtualization. So they're going to create a virtualization layer. Like suppose in your laptop, if you're using a Microsoft laptop, you also have you also have a concept of virtualization, guys. You can use Hyper-V, virtualization. You can create a virtualization and you can, download another, OS apart from your regular OS. Then you have servers on which you're going to deploy the application, your Linux servers, your Windows servers. Then you have database here, which is maybe your Oracle database or your, MySQL database where your customer data is, or your application data is stored. And then you have security and integration. Security means providing the security to your application. There are different security components are there, Prasad, which we are going to discuss in future. Okay, I'm not going to tell you right now everything because that is of no meaning. This whole course is designed in some steps. Everything you're going to understand in some or other modules. So the security component is going to provide a security to your application and your application infrastructure. Then integrating everything, integrating networking component with the security component, all the servers, the database, how to integrate everything. That also you have to take care. And then the runtimes. Runtime means your ID. You have to create a runtime environment. On the top of that, your application is going to be deployed. And this is your application. So these are the different kind of components which are used to create the application infra. On the top of it, you're going to run your application. Now, the main thing which you have to understand here, the difference between all the three different deployment models. So till now, we have understood what is traditional IT, where you have to manage everything. What is IaaS, where what you have to manage the infra, because infra is created by you, and all the virtualization hardware components are managed by vendor, that is AWS. When we are talking about PaaS, that is platform as a service, you don't have to worry about creating or managing the infra, because that infra is already provided as a platform to you by AWS. You only have to deploy the application, and this is very, very helpful for developers. Now let's check out the third solution, that is software as a service. Inside the software as a service, you don't have to worry about anything. You're getting a market ready product. You have to use a cloud-based product as a software. Let me give you a very good example. The example is Google Drive. Now look at this. If you see the diagram, everything is managed by vendor only. Vendor means AWS. So let me take an example of Google. Suppose if you're using a Google, we are using Google Drive. Google Drive is an example of software as a service, because Google Drive is a cloud storage. So inside the Google Drive, you can directly use. You can just create a Google account and you will get a Google Drive option, and you can start storing your pics or whatever information or whatever document are required to be stored on the Google or on that particular Google Drive. You can store that, and from anywhere you can access those documents. Only you need the access. Only you need the internet. So that is a complete product, a complete software. So it is an example of software as a service, where you are getting a complete market ready software which you can use as a service. So you don't have to manage anything. Are you managing Google Drive? No. Are you doing anything configuration of Google Drive? No. We are simply creating the folders or directly uploading the file, deleting the file, updating the file. That is only under our control. That means we are using that platform. We are not managing that platform. Okay. So I hope you understood the difference between. Okay, the vendor name is AWS. Yes. Yes, the vendor mentioned is AWS. Yes, Mani. So now you understood, because these are the building blocks of your cloud fundamental journey. So each and everything you should understand it very, very clearly. Now I'll repeat this whole thing again on a high level, and we are going to take a break. So when I'm talking about IaaS, PaaS, and SaaS, so look at this diagram. If you will move from IaaS to PaaS, you will have less control. Why IaaS is having more control? Because on IaaS, we are responsible for creating the infrastructure. We are using these services to create the application infrastructure from scratch. Because since we are selecting the network component, we are selecting the servers, we are selecting the databases, integrating everything, providing the security as per our business solutions, creating the runtime environments, deploying the application, everything is under our control only. That's why we have more control on the infra. But when you're going to move to PaaS, we will have less control. Why? Because when we are using platform as a service, only we are just deploying the application on a platform which is created by AWS. So AWS is only going to create the servers, you're going to arrange the load balancing, auto scaling, everything will be done from AWS end. You only have to worry about the application code. You can bring your application code and deploy on the AWS platform. Okay. So that is, you are having less control. Now, when you move to SaaS, you are having no control on the configuration. You are just using a software which is provided as a service. For example, S3 is there in AWS. That is also where there also you can store all the all your files and all. So you can create a S3 bucket and start storing the files. Are you configuring anything? No. So that's how you can also use the Google Drives. I've given an example. So Google Drive is a software as a service example which we are using in our day-to-day life. You can create you can store the files, you can create the folders, store the files in those folders also, but you are not doing any configuration, change or like managing your Google Drive. Everything is done from Google because it is a like a cloud product which is ready for use. That's why it is known as software as a service where you are not having any control. The least control is there. You can only control the data which you're storing on your Google Drive. So you can store how you can like what all files you are storing on that particular Google Drive. And suppose if you want to make it as public, you can make it as public URL. You can share the URL. Suppose like Prasad has stored some document, and now I want to access those documents. Then what is going to happen? It's going to provide me that Google Drive URL. He can give me the access. Then only I can access those documents. Okay, so that is how like you can have these different cloud service models. Let me also give you the example. Somebody is asking the example for infra as a service. For infra as a service, we have example as EC2. EC2, we are going to create the server from basic. You're going to do all the configuration. You are going to create a VPC. Those examples are infra as a service. Now, platform as a service in AWS, we have a service known as Elastic Beanstalk, which is an example of platform as a service. In like when you're using a Microsoft Azure, you can use Heroku, which is also an example of platform as a service. In the SaaS software as a service, we have example as Google Drive, which you can use as a cloud storage. Like if you have purchased a Lenovo computer, it will give you some OneDrive that you can use as a software. It is a cloud storage. You can use it as a software as a service. So runtime means runtime is an ID. It is an environment on the top of that you're going to create, like where you're going to run the application. So for example, Abhishek, whenever you create a Java application, so can you directly, first you have to, compile that application. So how you're compiling that application? You're compiling it on an ID. Okay, on an ID that is a Eclipse, you're going to compile the application. Then that particular application is going to provide you one byproduct. Suppose it has provided you var file. That is a byproduct. Then that file you're going to deploy on the server. So that is a runtime environment. Okay. Okay, guys. So let's go for break. It's already 10 minutes past 8. So let's go for 5 minutes break, and I'm going to see you after 5 minutes. Okay. So just clarification: can vendors access our server in pass? They have created the server. They're not going to they can access, but only for upgrading. Suppose if there is any upgradation activity, suppose they want to upgrade your software which we are using to deploy the application, they want to patch your operating system. For that only they're going to access your your servers. But don't worry, once I'm going to come to this topic, okay, then I'm going to tell you some more thing about the PaaS services. Okay. Yeah, we are going to cover containers as well. Okay. Okay, guys, let's go for break, and we're going to come back after this break. Okay, thank you. Hello everyone, welcome back. So let's start now. So now, till now, guys, okay, whatever concept I'm telling you, whatever example I'm giving you of any service, first understand, you're going to have a supported document that service you're going to learn in future, in the future modules with the supported resources. Currently, if I will give you any details about any particular service, you won't be able to understand. That's why whatever concept, like suppose we are learning cloud service models, here you have to understand what is IaaS, PaaS, and SaaS. Okay, that is the requirement. That's why they have created this course in a way that first we are going to learn about what is cloud computing, then we are going to go to other topics inside the AWS domain. Okay. Okay, guys. So let's move to another topic. Okay, now we're going to see what is cloud computing deployment models. What is cloud computing deployment model? So till now we have understood what are cloud computing service models. That is your IaaS, PaaS, and your SaaS. Now let's see what is cloud computing deployment models. So cloud computing deployment models are of three types. That is your public cloud. Okay, let me just write it over here. It will be efficient. Okay, cloud deployment model. First one is the public cloud. Second is your hybrid cloud. Third is your private cloud. Okay, so these are the three kind of deployment models. The public cloud, like inside the public cloud, where all these cloud resources like your servers and hardwares are owned by third party or the vendor. Now in our case, who is the vendor? AWS, and we are using all those like all this that hardware in the form of services. That is the public cloud. So what is the example of public cloud? Your AWS, which is going to provide you all the hardwares in the form of services. So they are owning all the hardware and just they are giving us in the form of services, and we are using this as a part of public cloud. So the example is AWS, Microsoft, GCP. These are all vendors which provide public cloud to all the customers like us. So that is public cloud. Now what is hybrid cloud? Hybrid cloud is a combination of a public cloud and private cloud. Okay, so that is a simple where you can use both public and private cloud. When you're having an infra where you want to use both kind of capabilities of cloud computing and your private cloud, that is considered as your hybrid cloud. Let me give an example. Suppose I was running a company from past 100 years. So in those past 100 years, there was no cloud concept. So then I have created few data centers across the globe where I was running my application, and I'm providing the content to all the global users. Okay. Now suppose like as the technology is getting evolved. So now when the cloud computing came to the market, I thought of creating a structure where I can use my on-premises or my traditional hardware as well as the advantages of cloud computing. That is my AWS services as well. So when I'm using both inside to create my application infrastructure, that is my own hardware which are inside my data centers. Also, I'm also using the hardware which is there on AWS platform, which is a cloud computing hardware. When I'm using both to create my application infrastructure, that is known as hybrid cloud, where I'm using both my public cloud and private cloud advantages. Okay, now let's go to private cloud. Private cloud means it is a cloud computing which is related to a particular individual or organization. So there are few hardware guys, okay, there are few hardwares which are created by few vendors. So those hardwares are placed inside the infra, like inside the on-premises or traditional infrastructures of companies, and from there they can use this cloud cloud services privately. So those services will be only assigned to that particular organization. They are not shared services. Inside the public cloud, whatever you are using, that will be under the shared services. In the private cloud, everything will be owned by you. That will be defined for you only. So there are few like machines are there which has to be installed inside the on-premises infrastructure or traditional infrastructures. Traditional infra or on-premises are same. On-premises means the that particular data center or that particular infrastructure is owned by a company. So if I'm talking about on-premises, infrastructure or I'm telling, like traditional infrastructure, both are same stuff. Okay, both are same thing, just an abbreviation. Okay, so inside the private cloud, suppose, like I've installed that particular hardware inside my on-premises infra, then I can use those services privately from my data center only. So these are the three deployment models. First one is public cloud, example is AWS or Microsoft or GCP, where we are using all these hardware which are provided by AWS and all other stuff like other market providers, and we're just renting out and using it under a shared tenancy. What is hybrid cloud? It is a combination of public and private cloud. So suppose if I am owning a particular, on-premises infrastructure, I can use that along with the AWS cloud. And what is private cloud? Private cloud, like as the name says, like when those cloud computing resources are used by a particular organization privately using some hardware. So that is the meaning of private cloud. Okay. Community cloud and all, these are not the cloud, these are not the cloud deployment models. Okay, community cloud for a particular community. So for example, I give you an example, like Oracle has a community cloud. So Oracle is having their own particular, like resources, guys. Like suppose they have own like particular applications which can be only be used by Oracle, which will be only be supporting on the Oracle cloud. Like we have SAP cloud. So those are community based for that particular community. For the people who are using Oracle, we are having who are using Oracle application, they can take the advantage of Oracle cloud. The people who are using SAP products, they can take the example of they can take the advantage of SAP cloud. So those are community cloud, but that community cloud is not the part of cloud deployment model. We have only three deployment model, that is public cloud, hybrid and private. The example of hybrid cloud is any what do you say, like any company who is owning their own infra and also using AWS. So for example, suppose there was any company who was any company known as XYZ. A company was there known as XYZ. So already the whole application was running on their on-premises infrastructure, which was owned by them. Now they found that there is something like cloud computing concept. AWS is a vendor. So why to buy more hardware? Let's use their hardware as a service. So what they did, they have called AWS, they have done some contract, and they have started using their services. So they have built some infra on AWS, they have built some infra on their, on their, on-premises, and they are collectively using a hybrid model where they are using both their public cloud and the private cloud. I hope it is clear. Amina, is it clear? Okay, somebody wants me to repeat public cloud. Public cloud, when it is a concept when all the cloud resources, that is your servers, your load balancer, databases, are owned by vendor. In our case, what is the vendor? The vendor is AWS, and we are only using it as a service in a shared manner. That is the meaning of public cloud. So currently the AWS is a public cloud provider. That is the example, Asha. I hope it is clear. Now Mani is asking why we need to go for private instead of public and hybrid. Actually, there are some companies, private, there are some companies there are some banking companies are there which don't want to expose their data on a public shared environment. So they want everything to be done on a private infra. That's why they need private cloud, because banking transactions are very, very secure. So that's why they need this private cloud kind of a infra. Okay, you can take the example of a banking. Okay, Rishikesh, Mani, is it clear? Okay, guys. So now you understood what are cloud deployment models, what are cloud service models. So these are the two components which are very important when you understand cloud computing. Okay. Yeah, these are secureless. Public and hybrid are secureless. Security is less as compared to private, but it is not like that. Your applications are not secure. There are applications which are running entirely on the public cloud, and those are secure. So it depends how you are maintaining the security of your application. But no doubt, whenever you are using anything on a private cloud, that is more secure as compared to hybrid and shared cloud. That is correct. Okay. Yes, Durga. You can use one server on-premises and second server on AWS for one application. That is the example of hybrid cloud, where you can use both AWS and on-premises environment to create the complete application infrastructure. Okay, yeah, you're correct. Okay, guys, so let's go ahead now. So let's see some similarities between AWS and traditional IT. So what they are going to tell you in this particular slide, that the functionality is same. So let's check out. Suppose inside the traditional on-premises IT space, we were having firewalls. When I'm talking about security layer, for the application security layer, we were having the firewalls, we were having ACS, we were having security administrators who were creating the security for our application. Now in AWS, these components are renamed as security groups, your network ACS, your IAM. So these are the things which we are going to discuss in detail. I'm not going to go in detail about each and everything because we have a particular module for each and everything. So just a renaming is there. The concept is same. Whatever we were using on premises, based on that only the all these virtual servers, virtual components are created, because those components were there which were running from 19th century, the evolution of IT. So the same components are there in the traditional, only we are renaming it inside the AWS. So like for example, firewalls are renamed as security groups, ACLs are renamed as network ACL, administrators are renamed as IAM. Now when I'm going to networking layer, we have routers, network pipelines, switches. These all are network components for traditional infra. But when I'm using it inside the AWS, I'm having an elastic load balancer, I'm having an AWS VPC, virtual private cloud. So just a renaming. The functionality is same. Now let's check out the compute layer. Inside the compute, if you are going for traditional infra, we have on-premises services, because on-premises means owned by a company. But when I'm going in AWS, I'm having EC2 instances. So these EC2 instances are owned by vendors. I'm usually using it as a service to create the virtual machines. Now when I'm moving to storage and database layer, I'm having the databases there, the storage are there, DAS, SAN, NAS, these are the type of storages. You have RDBMS, that is your database. Same way, when you are talking about these components inside AWS, they are renamed as Amazon EBS, that is your block storage. Your EFS, I've told you, EFS is nothing but your like file storages. And then you have S3, that is your object based storage. You have RDS, which is your database. So here they're telling the similarity is there. Okay, similarity is there, and only the renaming is there. We are just renaming it. Hey, somebody was asking me what is virtualization, so let me just tell you. I think he or she have not joined the class yesterday. So virtualization means creation of virtual version of something, such as server or storage. So like you have a physical hardware. That physical hardware, if it belongs to you, if you can touch that hardware, that is a physical hardware. If suppose I am giving you one, I have created a virtual version of that particular physical hardware and I provide it to you, that will be a virtualization. With the help of the virtualization technology, I have created that physical hardware into a virtual hardware. Physical server into a virtual server. So how we are creating this physical server to virtual server? With the help of virtualization. Okay, I think it is clear. Okay guys, so let's check out. So this is, here they are just explaining how we are renaming the component name inside AWS and how we call it inside the traditional infra. That's it. Okay, let's take the key takeaways of this particular section. So cloud computing is an on-demand delivery of IT resources via the internet with pay-as-you-go pricing. Yes, it is an on-demand delivery of all the IT resources like networking, your servers, your databases, etc., your storages also, and how you can access those virtual components using the internet. And what is the pricing model? It is pay as you go, which means whatever you are going to use, you are going to pay for that. That's it. Cloud computing enables you to think of your infrastructure as a software. Definitely. When we are using the traditional computing, what we were thinking infra as a hardware, because we were owning all the infrastructure. That's why infra was considered as a hardware. But now, when we are using all those stuff inside cloud computing, what we have to think? We have to think the infra as a software, because AWS is providing us all those hardware in the form of services which we can use to create the application infrastructure. Okay. Now, what are the three different type of cloud service models? IaaS, PaaS, and SaaS. IaaS is known as infra as a service, where we are going to create the infra. We are having the more control on the infra. Then we have platform as a service, where a platform has been provided, and on the top of that, developers is going to deploy the application. We are having less control on the infra. And finally, we have software as a service. Software as a service is a market-ready software, a product which is given to you, which is a cloud product. For example, Google Drive, where you can use the product directly. You don't have to configure anything, and you are having no control on this particular software. You can only control the data which you are storing on that particular software. Now, what are the three type of cloud deployment models? The first one is your cloud, which is known as your private public cloud. Then you have hybrid cloud, and finally you have your private cloud or on-premises cloud. And we have already seen the difference between them. And at last, the last point which we have learned here, almost anything you can implement with traditional IT can also be implemented as an AWS cloud computing service. So for example, look at this. Whatever infra was here, okay, whatever component for a particular infra was here on traditional, same is under AWS also, only the naming is different. That's it. So nothing is like that. There is no limitation that you cannot use this particular component inside AWS. You can use it in a better and efficient way, and you will have more services apart from the traditional. Now people are not creating the traditional infra. They're moving they're moving to AWS only, guys. Okay. So now let's move to the section 2, that is advantages of your advantages. Ethel, I'm telling you, we are having a whole section of what is object, what is block. If I'll tell you now, you won't be able to understand. Please, whatever I'm telling you, just listen to that. At the end of the day, once we will complete the course, then you tell me that what is not covered. Everything will be covered. Please have some patience. Okay. I'm going to tell you about everything, what is block-based storage, what is object, but let's reach out to that particular point. Okay. If I tell you now, it will be difficult for others also to understand. Okay. So please have some patience. Just understand what I'm explaining you. Okay. You will get all the details. Don't worry. Yeah. ACS is, this is a networking component. Okay. So we will discuss inside the network layer money. So what are ACS and all? These are used to provide the security to your infra. This you should understand now. Okay. Okay, guys. So let's check out the section 2. That is advantages of cloud computing. So first of all is trade capital expense for variable expense. So what is trade capital expense? Let's understand this. So capital expense is, when you're owing something and you are maintaining that particular infra for the lifetime, that is a trade capital expense. So for example, if suppose Manan has created Manan has created an IT company and he has owned a particular data center. So that data center, the cost of the land, the cost of creating that particular hardware, that data center, cost of bringing all the components, cost of bringing all the cooling components, the security of particular infra, everything comes under trade capital expense, where you are, expensing your money in creating that particular infra. Now, what is variable expense? Variable expense means the services which we are using on renting. You are not having any trade capital. You are not, creating any infra. You are just using it as an, you are just renting out the infra from AWS for some particular time, and whatever infra which you are using, for that you are paying. So that is your variable expense, which comes under AWS or cloud computing model. So if you will check this, this left side diagram, that's capital. Data center investment based on forecast. Definitely, when you're creating a data center today and tomorrow, if suppose after 1 year you want to, increase your application features, and if you want to increase your business, then you need more machines, more storages. So all those are the part of trade capital expense, because you are owning everything, you are maintaining everything inside a data center which is owned by you. Now, what is variable expense, which is the part of cloud computing, where you are paying only for the amount you consume. For today, if I am creating 5 servers and I am running it for a year, then I'll be only charged for those 5 servers. Tomorrow, if suppose I don't want to use those servers, I can terminate or I can delete those servers simply, and from that point of time, the charging will be stopped because I'm not using any services. That's why it is a variable expense. I'm not allocating a fixed amount for a particular data center asset. I'm just using it a variable expense, where I'm just paying only for the amount I am consuming, the amount of services which I am consuming for my application. If suppose I'm running a single server for one day, I'll only charge for a single server. That is a variable expense. You have a trade capital expense inside traditional infra. You have variable expense inside your cloud computing infrastructure. Okay. Now, massive economies of scale. This is the second advantage. So, because of aggregated use from all the customers, AWS can achieve higher economies of scale and pass savings to the customer. But let me give you an example here. So, like as the when AWS has launched their first service in 2006, they would be having a few customers, and the services would be on a higher rate. So let's take an example of EC2. So when they have launched a particular EC2 service, the costing of a particular server per hour was around $10. Now over the period of time, AWS has AWS got multiple customers. They've increased the customer base. AWS has increased a lot. So when they have a huge customer base, then when they are having huge customer base, then that is a profit for them. And how they are sharing the profit to us customer by reducing the prices of each service. So now like after 21 years, the same particular service will cost you around $1 because more customers are there, more volume customers are there. So how they are giving a profit to the customers by reducing the service cost. If any service was costing 20 years back $10, it is now costing only $1 or $2. So that is the advantage. It is a win-win situation. So tomorrow, if more customers are coming to AWS platform, it can be a case AWS will make that service free for use. They will charge for some other services. Okay, that's how it's a massive economies of scale. So as the AWS is going to, grow, it is also helping us to get some profit out of that by reducing the price of each service which we are going to create the infra. Okay, yes, it is bulk customer costless. Very good. So when they are having bulk customer, if they are having more customer, they're going to give that customer some profit, by discounting each AWS services which are used to create the infra. So hope you understood this massive economies of scale. Let's go ahead now. The third one is stop guessing capacity. The same thing. What was the issue in traditional cloud computing? We were guessing. What were you guessing? Okay, today we are having this kind of a customer traffic. Suppose 1 lakh customers are interacting with our application each day. Now we are thinking that after 6 months, this customer traffic will move to 2 lakhs. That is only we are guessing, and based on the guess, we have ordered the infra because when we are using the traditional computing, we are not going to get infra in a on demand. You have to wait for some. Maybe we have to wait for a few days. Maybe we have to wait for few months to get all the infra ready for the usage for deploying the application. Okay, so that's why everything was on guessing. So suppose if suppose my guess was not correct, so that means I'm overestimating the server capacity. So there are two terms, okay, in guessing. One is overestimating server capacity and one is underestimating server capacity. So to eliminate the guessing capacity, we have moved to cloud computing. Now what is overestimating server capacity? Now let's see the same example. I've ordered machine for 2 lakh customers. Now after 6 months, I can only see there was a little, there was a little increase in customer traffic. That was from 1 lakh to 1 lakh 20. So now look at this. All the resources are idle here. We have got the server, we have configured the server for around 2 lakh people who are going to hit our application daily. But now we only are having 1,20,000 customers hitting our application. That is a customer traffic. And because of that, look at this. The capacity utilization of each and every server is less. We have overestimated the server capacity. How we have overestimated the server capacity? What we have thought that after 6 months we are going to have 2 lakh customers. But now we are only having 1,20,000 customers, and because of that we are not able to use our customer use our servers efficiently. And because of that, most of the resources inside our machines are getting idle. We're not able to use that particular server effectively. That's why it is overestimated server capacity, where we have overestimated the server capacity, but we are not getting that kind of a response. Now let's see what is underestimated server capacity. Same thing. After 6 months, I was thinking about 2 lakh customers. Now I got 3 lakh customers hitting. My application has hit the market, and now I'm getting like 3x customers. But I have infra only to support 2x customers. So that in that time, if I'm trying to handle the customer traffic with that particular infra, those those servers which are supporting the application will get exhausted. Look at the diagram. All the infras are getting exhausted to 100%, and this can bring the application down because that infra is not able to support the customer traffic. That's why it is underestimated the server capacity. We are just guessing this, and when we're guessing, it can be somewhere you will overestimate the server capacity or you're going to underestimate the server capacity. So when you are going for this cloud computing model, you have to stop guessing the capacity. Everything will be done on demand. So today, if you are running your application on 10 servers, tomorrow you think 2 more servers are required, just create the servers in few clicks, add them in your infra as per the demand. Now suppose after 6 weeks you found there is a decrease in the customer traffic, you can delete the extra machines so that you won't be charged more. Everything will be on demand. That is the best feature. You're getting everything on demand. You don't have to guess everything. Yes, you can scale up. Yes, Vandana, you can scale up. What is some okay. So Raghuveer, you can hear me, correct? My screen is not hung. Okay, so scaling up, we also have our auto scaling feature that where you can scale up and scale down automatically. That we are going to learn in in the coming classes. But for now, you understood what do you mean by guessing capacity. With the help of guessing, what all problems are coming. We were having there were 2 problems. First of all, either we will go for overestimating the server capacity or we are going to underestimate the server capacity. It is not going to be a bullseye that whatever you have predicted that will be right, because we are just guessing it. We don't know if a product will be available in the market for next 6 months. If we are not launching a good features, we are not providing a good solution to the customer, the customer traffic can be declined gradually. Okay, so we have to stop guessing the capacity when it comes to cloud computing, because everything is available. The scaling is done. The scaling the infra up or scaling the infra down is done inside cloud computing on demand. Okay, guys. So let's check out the another advantage: increase speed and agility. So when you are using your traditional infra, first I'm going to explain you everything about traditional. Then we are going to move to cloud computing infra. So suppose if you see the left diagram, this is the purchasing request. So you have purchased. Suppose someone is having this traditional infra and they have ordered. So now that order they will get in some weeks, not instantly. Suppose if today I am ordering 100 servers from any company, will I get it on demand? No. It will take some few weeks, maybe it will take few months. That's why the whole process of creating or deploying that application is not smooth. It is very, very slow. It is not agile. Agile means continuous. It is not continuous. There is a breakthrough. Agility is not there in the traditional, because when we are ordering something, we have to wait for some time till the time we will get everything. Once you will get everything in your data center, then you have to ask your hardware engineers to to go ahead and assemble everything, integrate everything. So it will take some times, maybe a week or month time to get the infra ready. But this kind of a problem is eliminated with the help of cloud computing, because it will take only minutes for you to create a new server, to add a new server into your infrastructure, to deploy the application. These all things will be done within few minutes. So now look at this. From weeks or month time, we have reduced to minutes. So that is very powerful. That's why cloud computing is very powerful. Everything is on demand. The process is very speedy. So suppose you are working with a customer. So customers told, okay, tomorrow we are going to after 2 days we are going to launch a new feature. So it has asked Abhishek, that Abhishek, you are working as a cloud engineer, please create an infra with this requirement for hosting this particular application component. So Abhishek can create the whole infra within few hours. Within few minutes, he can create the servers. So that's fast, and then the process is very like agile. Agile means it is continuous. There's no break in the process. It is very much agile, and it is very speedy as compared to traditional. Okay, guys. So let's check out another difference. Is for stop spending money on running and maintaining data centers. Suppose when you're owning any data center, that time you have to bear a lot of cost. The cost of the land, if you buy the land, if you rent out the land, then you have to cost of building the whole data center. After that, the people who are working, the staff who is working inside the data center, you have to pay salary to them also. Then you have to bring all the cooling components which is going to maintain the temperature of the infra of that particular data center. Then you have to buy all the hardware components on which you're going to deploy the application. So this is the overall cost of running a single data center, which is very, very huge. So, when you're using a traditional, then only you have to spend all this kind of a costing, all this kind of a bills. But suppose if you're using a cloud computing model, cloud computing infrastructure, that time all these things, all these expenditure will come to zero, because you don't have to maintain any data center. And now we have the money that we can use for promoting our application. That money we can use for advertising our application. We can use it for creating more features of our application. So then you can use this money, because you are saving a lot of money because you don't own any data center. Okay. Okay, there's a question from Manan. Let me take this question. How you can adjust the memory, Kanan? Okay, today if I will ask you, okay, suppose your application is running on your computer only. Okay, like if your application is running on your computer only money, and tomorrow if your application resources are getting exhausted, so can you increase the RAM like on demand? No, you cannot increase the RAM on demand. You have to shut down the application. You have to take your laptop to the vendor. Then he will put more RAM in your laptop. Then you will come back to your home. You will start your laptop. You will start the application server. Then the application will be up. It may take a day also. Your application will be down for a day. That's why we create multiple servers. And one more thing. Suppose if you are using a single server money and your server went down, that means your whole application is down. And when we are running the application on multiple servers, inside the multiple server, if any single server is down, then two other servers are there to host your application. There won't be any single point of failure. I hope you got the answer. Okay. So let's go ahead. Yeah, zero downtime you can consider. Yes. That's why we use high available infrastructure, so that we don't get any downtime. Okay, actually, this resource pooling, Abhishek, okay, actually this concept is, like when you're using the resources of multiple accounts, so that concept we are not going to learn here, but I'm going to tell you more about the resource pooling tomorrow. That I'll take it as a note and I'll tell you some details about resource pooling, that how you can use resource pooling. But we're not going to learn here in this thing, but I'm going to tell you tomorrow. I'll just write down, okay? Resource pooling I'm going to tell you tomorrow. Okay guys, so one more advantage is here, go global in minutes. So suppose, let's take first example of on-premise your traditional infra. Currently, if you have created your application data center inside India, okay, though you can you can entertain all the global customers, but there will be some latency. If suppose any request is coming from US, that request is going to travel from US to your server, which is in India. There will be some latency. So that's why to reduce the latency, you have to create more data centers. Suppose in US, few data centers in Europe. That will cost you a lot. That will take a lot of time. That's why going global when you're using traditional database and traditional computing models, it takes a lot of years. Maybe in 5 years you're going to create a global setup. That kind of a time it will take. You need more manpower. You have to hire more people on each location. So a lot of costing will be there. Lots of time will be wasted. But suppose if you want to use cloud computing model, if you want to go global in minutes, you can just simply choose any region. What is AWS region and all? I'm going to tell you in the module number 3. So there are different regions where AWS has created the infra. So you can suppose currently your infra is inside India. Now you want to create infra on AWS location. So you can just change the location and then just create the infra. That means you are going global in minute. You can just replicate the infra using some automations. So that's how you are growing global in minutes. So you are having your servers inside India. Now you also want to set up in US. You can set up within few minutes. That's why you can go global in minutes. You can launch any servers in any global region using your AWS services. That's why it is going global in minutes. But that is not possible inside the traditional computing models. Okay, let's check out what's here in. Okay, so let's check out what was here in section 2 key takeaways. First of all, trade capital expense for variable expenses. We know trade capital expense goes for traditional computing, where we have to pay a lot of money of creating all the assets, and variable expense goes for cloud computing models, where we only have to pay for the amount of resources which we are consuming or using. Benefits from massive economies of scale. As your AWS is going to grow, is going to provide benefit to customer as well by reducing the rate of each and every services which you are using. Stop guessing capacity. We're not going to guess the capacity. Okay, we are just going to implement on demand. Based on the customer demand, we're going to implement. That's it. Increase speed and agility. Definitely, within few clicks, you can create a new machine. You can add that machine in your infra. So the process is very, very fast and very much agile. Stop spending money on running and maintaining data centers. We are not maintaining any data center. That's why we are not spending any money. So that money you can save and you can spend on your product development. Go global in minutes. Definitely, we are going global in minutes. We don't have to create a data center on each and every location. That's why we can just simply click few services and we can create those services inside that particular region, AWS region, and that's how we can go global within few minutes. Okay. So now let's move to section number 3, which is introduction to Amazon Web Services. So Amazon Web Services is a public cloud computing provider. It is to provide the cloud computing services on a public cloud. It's a public cloud which is to provide the cloud computing services on demand. That is a simple example of a definition of AWS, Amazon Web Services, which provides you cloud computing services on demand on public cloud platform. Okay, let's check out. So there is one first concept is that what are web services? So actually, web services is a framework which is used for conversation between the client and server, between two machines. So if you will check the diagram, let's just check the diagram. Okay, so what is client? Suppose Prasad is there. Prasad is trying to access Amazon.com from his machine. So his machine is client. So now, suppose he has logged into Amazon.com and he is trying to look for some, pair of jeans. So he has searched jeans. Now that request will go to Amazon server, the server which is hosting the Amazon.com. So that request, the request from Prasad's client machine will go to server. That is a request, and now the server is going to respond to client machine. Okay, and what response will get? All the details about the jeans. So it's going to collect all the details. It is going to send it to Prasad, and then Prasad is going to see all the different kind of jeans available on Amazon.com. So that's how the communication goes on, and all the communication going through the public network, that is your internet. So inside this model, we have one client machine, we have the server machine, and this is how the interaction goes on. Client is going to send the request. Suppose in the case of client, we have Prasad who is looking out for pair of jeans from Amazon.com. So he has sent out a request that he want to see all the jeans. So now that request goes to the Amazon.com server. Amazon.com server has accumulated all the details, and that response has been sent to client machine, that is Prasad machine, and now Prasad can see all the jeans available on Amazon.com application. So that's how the communication goes on. Now, how these machines are interacting, how this client machine is interacting to the server machine. It is done with the help of web services. So let's check out this definition also. Now you understood in a very simple way how the communication is going on. This request going, response is coming to the client machine. All those is done. The communication between the two servers is done with the help of a web server. Okay, web services. So a web services is any piece of software that marks itself available over the internet and use a standardized format such as extensible markup language XML or JSON object notification. So these are the two kind of a standardized format are there on which the request flow. So whenever somebody is trying to, suppose Prasad is trying to request for jeans, then all the requests will flow in the form of XML or JSON format over the internet, and then it will reach the server machine, and the response will be also in the same format. So it is using this standardized format for the communication. Okay, and it's a link for the request and the response of an application, programming API, like API interaction. So what is API? There's a difference between web services and API also. Let me take the question, then I will tell you. Okay, what is internet? Internet is a public internet. Okay, like it is a what is it? Example of a wide network. Okay, there's a LAN, WAN, and MAN are there. So it is a wide area network. Is an example of wide area network from where you can connect yourself to any large geographical location. Got it? With the help of internet. So suppose, like in your mobile, you're trying to access google.com, or suppose you're trying to access Facebook, and you're connecting to your friend living in US. How you can do that? With the help of internet. It is a wide area network money. Okay, so it is an example of wide area network which is used for connecting you to the world. That is the meaning of internet. I hope it is clear. Okay guys, now I will tell you one more concept and we are going to wrap up. So what is the difference between web services and API? So I told you what is web services. Web services are used for communicating, for setting up a communication between your two servers, client and your between two machines. It can be a client machine or server machine. Now what is API? APIs are it is an application programming interface which is software to allow communication between two applications. So what was the application? Suppose, let me give you an example. I think you all would have booked any ticket, train ticket through, suppose, Paytm, or flight ticket through through your I think Amazon website or Flipkart. I would say GoIBivo. Suppose you are booking a ticket from GoIBivo. So GoIBivo, you are trying to book a SpiceJet flight, guys. Okay. So what will happen? These are two different applications. GoIBivo is a vendor, and exactly how you SpiceJet is the service provider. It is an airline service provider. So what is that? So how they are getting connected? They're getting connected through API. So suppose I am sending, I have logged into goibivo.com and I tried to book the ticket. So I have booked the ticket through a GoIBivo platform. But how the GoIBivo platform will get to know that how many seats are available on that particular SpiceJet airlines. So it is going to send a request to SpiceJet. SpiceJet is going to check whether seats are available. Then it's going to respond back to application GoIBivo. Then it will display the seat. You will select the seat and you will do the payment. Then the payment will go to GoIBivo. GoIBivo will take the payment and is going to send some part to this SpiceJet. Now how these two applications are getting communicated? With the help of API. So you used to create APIs because APIs are very secure, and these developers, you're not going to create the API when you're working as an infra engineer. But if you are having any developer roles, then you're going to create the APIs. So these application programming interfaces are used for communication between two softwares. These are very secure because GoIBivo, because this SpiceJet don't want to expose its whole database and application to GoIBivo. It don't want to give the permission. So that's why they told that we are going to interact with the API. You just send me the request securely. I'm going to provide you the information so that my application resources won't be and my whole application security won't be exposed to you. That's why the whole communication is going through API channel only. Now understand the difference, because there's a difference between web service and API. Many people think web service and API is the same only, but no, there's a difference. Web services are used for communication between two servers, and APIs are used to communicate between two softwares. Okay, so there is a difference. So we're going to continue with this. What is AWS tomorrow? It's already 9 o'clock. So no, API as a gateway is a service. API as a gateway is a different service study. Okay, yeah, you can consider it is a gateway from where all the requests will come. Okay, but inside AWS we also have a API gateway service. Okay, did you change the slide, sir? Yeah, yeah. Just now I've changed the slide. We're going to discuss this slide tomorrow. So, guys, if you have any questions, you can ask me. I'm going to wait for a few more minutes. Please show next slide. Previous slide. This one you want to see? This one, Abhishek. Okay, guys. So I'm going to just provide you one form. Please, like just rate my training, because this will help me also. Just copy this and let me put it in the chat. Any question you can just tell me. Hi sir, I've joined after 7:45 p.m. because I'm working up to 7 p.m. So didn't hurt. Grace, I think you have to join it on the time because these are not the recorded sessions. So please join it on the time. And I'll do one thing. Okay, so tomorrow, each day, whenever I will start a session, I'm going to just revise all the yesterday's concepts. So please tomorrow join on the time, and I'm going to just revise the concepts. Okay. Okay. So gateway is an entry point. Gateway is an entry point from where your request will come. So for example, suppose money, you are having your home. You are having a gate. There, the main gate. From main gate only, you're going to enter your home. You're going to enter out. You're going to go out from your home. If any new your relative or friend will come, they will enter through that gate only. So let's consider this gateway as an application gate, from where your application request will hit your applications. Okay. Suppose if I want to access, like any part of any application, and whenever I'm searching on that application, that request will go through that application gateway. Okay. That is the application gateway. Okay, guys. No, recording are not available. That's why I'm telling you, please join on time, because there won't be any recording available for you guys. That's why. So please concentrate on my class. Okay, so yeah, these slides you will get. Abhijit, once you will get the access for this canvas, then under each module there is one student guide. You can click on the student guide. And you will find Abhishek as locations, and this topic will come inside the AWS infrastructure. We're going to see how to create the global infra, how the AWS has created a global infra. Then I'm going to explain you the concept of edge location in detail. So have some patience, Abhishek. So look at this. So this is the whole material which I'm just presenting you. You will get the access once you will get the canvas access, and you will get all this access maybe in few days. Maybe by Monday you will get the access, guys. Okay, guys. So thank you so much. Any other questions? I'll stay for 1 or 2 more minutes. We can discuss. If not, then we can wrap up and we'll see each other tomorrow. And yeah, that's it. Okay, I'll wait for another minute. Sure, Sapna. I will try to show it a bit. Definitely. But if you're understanding it, that is the best part. Okay, so thank you so much, guys, for joining the session. I'll see you guys tomorrow. Have a good night. Bye-bye. Yes, we use it for authentication purpose. No, Abhishek, my contact details are not the part of my contract. I can't share you my personal details. Whatever things you have to communicate, the communication will go through Ethnus platform only. Okay, so I can't share my personal details. Sorry. There is a Prasad. It takes some time, okay, to create access for each and everyone. That's why they're going to provide in few days. So don't worry, you will get the access. Okay, and you can ping the group. The management group. You can ping them, and so that they can speed up the process, because this is not in my hand. Okay, Prasad, you can just check out with them. Okay, guys, thank you so much for your time. We're going to see each other tomorrow. Have a good night. Take care. Bye bye. See you tomorrow.